Hey guys, welcome back. Today we're still working on solving differential equations using separation of variables, but I'm going to add one new type of problem today, and I will tell you this is a very, very, very common problem, a free response question on the AP exam, okay? So let's start like normal. Go ahead and separate the variables like you know you should and go as far as you can. So hopefully you did the first step with no trouble. Okay, so now when we integrate this, the right side, no big deal. That will be x squared plus c. Don't forget that plus c. On the left side, hopefully you remember this is really junk to the first power. And when it's to the first power in the denominator, that is natural log. So we have the natural log of y minus 1 divided by the derivative of the inside, which is 1. But be careful to always say divide by the derivative of the inside, because if that had been 1 minus y in there, the derivative of the inside would be negative 1, and that'll get you. And that'll get you on the AP exam. They do that a lot. Okay, so now the next issue that's going to be a little confusing, that's why I saved this problem to do as a separate lesson. Now, how do you get the y away from that natural log? How do we separate this? How do you solve for y? Well, to undo a natural log, the inverse of natural log is e. So we're going to exponentiate both sides. And here's how you do that. It's going to seem hard at first, but you just do it over and over again until you get used to it. We're going to exponentiate and put this in parentheses and exponentiate. Okay? Now the e and the natural log cancel each other out, and you get just y minus 1. Now on the right side, we have another crazy thing that's going to happen here because of this c. So off to the side, I'm going to show you something. If you know, and you do know, x squared times x cubed is x to the 5th, right? In multiplication, you can add, right? Well, that's kind of like saying x squared times x cubed is the same as x to the 2 plus 3, right? We just add these. Well, we're going to go backwards. We're going to go from here where you see the addition and rewrite it as multiplication. So e to the x squared plus c is the same as e to the x squared times e to the c. Notice that that's multiplication, and that's the same as adding the exponents. All right, now one more glitch. E to the c, if c is a constant that you don't even know what it is, then e to the c is still a constant that you don't know what it is, so you replace e to the c with just c. All right, so let me do that again for you over here within the problem. So when I rewrite e to the x squared plus c, I'm going to write it as e to the x squared times e to the c, and then I'm going to replace e to the c with just c. Okay? Now get y by itself, add 1, and your final answer will be c e to the x squared plus 1. Okay, so this is a very, very, very common problem on the AP exam. It's a free response question. Sometimes it's even worth 6 points. This is a big one. Make sure you know how to do this, okay? Let's do another one just like it. So if you thought you understood that last problem, try this one on your own. Hit pause. If not, I will do it for you, and you can do it with me. All right, separate the variables. Integrate both sides. On the right side, I always do the right side first so I can try to remember the plus c. This would be 3x cubed over 3, which is x cubed. Okay, and on the left side, this is the natural log of 2 minus y divided by the derivative of the inside, which is a negative 1. Okay? Now get rid of your negative. If there's anything in front of the natural log, always get rid of that before exponentiating. So I'm going to multiply everything by negative 1. So we get a negative x cubed. And remember, negative 1 times c, we still just write c because it's still a constant that I don't know what it is. Now to undo the natural log, we exponentiate. And because we no longer have the natural log, we're not going to write the absolute values anymore. So we have 2 minus y equals. This is e to the negative x cubed times e to the c, and you can replace that e to the c with just c. Okay? Now subtract 2 on both sides, and we get negative y equals minus 2. Okay? Divide by negative 1, or multiply by negative 1, and you can still just write a c here, or negative c. It actually doesn't matter. We'd all get the same answer in the end if we had to plug in a point. Okay? And that's our final answer. Now, whether you wrote c or negative c, it's fine. You can do it either way. And that's it. Okay? Hopefully that went well. Hopefully you got that. All right, let me show you another one that can be a little bit tricky. Okay, these next couple, they aren't anything new. It's just going to be like, these might have tricked you if you didn't hear it from me a little bit beforehand. All right, this one. How do you separate these variables? Remember, you're not allowed to use addition and subtraction to separate variables. Not that that would make sense for this one anyway. You're only allowed to use multiplication and division. Yet how the heck do I do that with this? Well, that's a hint. You're only allowed to use multiplication and division. So you need to rewrite this problem so that it looks like multiplication or division. Does that give you a clue? The trick is when you subtract exponents, that's the same as division. So we're going to rewrite this. Oops, sorry. One moment, please. Okay, so we're going to rewrite this as the original problem before we separate variables. This is the same as e to the x divided by e to the y. Because remember, in division, if the base is the same, you subtract the exponents. So these are the same thing. Now it looks like separation of variables. So now I'm going to separate the variables, move the e to the y to the left. Okay, and now just a little review. Remember how e works. I'm going to do it off to the side. Remember, if we integrate e to the 3x, it's e to the 3x divided by 3. Okay? So integrate both sides. The integral of e to the y is e to the y. And the integral of e to the x is e to the x plus c. I should have done the right side first. Okay, now we just have to get y out of there. How do you get the y by itself? Natural log of both sides. Take the natural log of both sides, put it in parentheses, and stick a natural log out front. The natural log and the e undo each other, and you get y equals the natural log of, it has to be in parentheses, e to the x plus c. Okay, now, because it's natural log, I should have absolute values there, but e is always positive, so, well, I'll put the absolute values there. Not going to hurt. Okay? So, that's how you deal with e. Focus on this guy. Okay, make sure you rewrite it as division or multiplication. All right, one more little glitch of a problem. Okay, this one. This is also a very common free response question. It's not usually y's and x's, though. They might do it in a word problem where you have w's and t's, but whatever. This doesn't immediately look like separation of variables. It doesn't have x's and y's mixed together. So this often tricks kids. But this denominator, the dx, this tells you what you're allowed to integrate. When you multiply by that dx, it tells you you need only x's over there. So you still have to separate these variables. And that's not hard to do once you recognize that you have to. The hard part is recognizing that this is still separation of variables when there's even though there's only one variable. So you still have to separate the variables, move the y cubed over. And you can leave the 2 here, or you could have moved it. It doesn't matter. Okay? Now you still have to integrate both sides. And on the right side, what is the integral of 2 with respect to x? It's 2x. If it had been with respect to t, it would be 2t. Okay, and then on the right side, y to the 4th over 4. Okay, from here, it's pretty much the same thing you've been doing. It's just that this one's difficult to recognize how to get started. Okay? So multiplying by 4, I get 8x plus still c. And then 4th root of both sides, 8x plus c. And a technicality that I didn't really mean to trick you with, when you do a 4th root, just like when you do a square root, you actually need a plus or minus. Okay, so hopefully you guys are doing okay. I'm going to give you another worksheet today, and I'm also going to be making a few video requests. I'll do that next and post those too. Bye. Have a good day. Good luck.